I believe, unlike everybody else from MariaDB Corporation here, I am not a developer. Shame on me, I am from services. And that's what I do for the last 15 years. I'm a support engineer for MySQL of different kinds and now of all kinds, thanks to MariaDB. Since I quit Oracle, I went public and I write about my work and work-related matters everywhere. In a separate blog on Facebook, everybody is annoyed, probably at some stage with my friends, with posts about bugs, Twitter and everywhere. I also like to participate in FOSDEM. This year I was one of those guys whose stock was not selected for the main track, but MariaDB kindly asked me to try to present one of them. Many of my FOSDEM talks were of a kind something for MySQL DBAs. People were joking like one day we'll give a talk, dev now for MySQL DBAs. It would probably make some sense. I believe today's talk might make more sense. What I would like to highlight about all kinds of slides I ever produced, they have a lot of words and links to everything. So they were already published everywhere, Facebook and elsewhere. So click on all those links, you may get way more useful information than from me talking on this. So this talk is a kind of continuation of what Peter Zaitsev tried to present actually. It's about observability. It's about getting information on what happens inside of your MariaDB server. This is a quick review of all the ways I know to get the insights. So some of these first items were already listed by Peter Zaitsev as a sources of profiling information. By profiling I mean periodically collecting of something related to the way your program, in our case MariaDB server, works. I have something to add. There is also a user start that was not mentioned. There was the very first community contribution from Jeremy called to MySQL that still works in MariaDB profiles, specifically added to find out where time is spent during the execution of specific queries. So it was split into stages and carefully measured up to, I don't know, milliseconds at least, as far as I remember. There is also performance schema and everything else. From all that, today I would like to concentrate at the lowest level. You can get a lot of insights by just watching the traffic to MariaDB server and from it, capturing packages, parsing them and understanding the timing for these packages. So that's what the entire business of Vivid Cortex is built on, for example. They are monitoring MySQL, MariaDB, whatever servers by watching the traffic in between. So of all these tools, they provide a different detailization of information. Each of them has its own purpose with a different price. So what I care about in support as somebody who has to deal with often very high load at customer side, that the observer, the tools used to capture the information I need, do not influence the process I'm trying to capture. So that's why at some stage I came to the need to use operating system level tools. Today we'll speak specifically about Linux. And in case of Linux, I went over several stages. Like 3 years ago, I presented using profilers for MySQL DB, so I already was at that stage that you need to apply post-level profiling tools, different from them. And later I moved to even more advanced, more lightweight profiling tools already available in recent Linux kernels. That's what I suggest you to use. So I will not try to explain you exactly what it's about. I will better say what this session is specifically not about. It's not about using the performance schema of all that stuff. Even though it's a bit contradictory to the initial idea of adding the performance schema as a lightweight and very specific profiling metrics and specific performance counters to each and every other line of the code. So of all that, the other tools will be also mentioned. Some of them just have too much input, some of them require debug binaries or specifically build binaries like gprof that really developers would prefer to use, but we do not have that binaries in production. That would be too slow. Specifically, why not about performance schema? I have like several items to explain. The simplest is, it was already questioned, why is it so that in case of MariaDB, performance schema by default is not enabled. Moreover, in case of MariaDB, in all released version, performance schema is a bit outdated. So let me move on to that part. Outdated, it patches MariaDB version 5.6. We will get a part of 5.7 performance schema instrumentation in version 10.5. That part, I hope, will cover the memory allocation. It may not cover replication part, because replication is very different. So something easy to port will be added. But we are lagging. The worst thing is that it's not enabled. Other bad things come from my experience. So unfortunately, even if it's enabled, it may be too complex to get the information you need, and unfortunately up to now the performance schema instrumentation is not on every other line of the code. If you listen to Georgi Kadino, he made several presentations where he explains how easy it is to add performance schema instrumentation, and it should be every second line in your code. It's not yet there. Specifically, it's not yet, for example, in Galera library. You cannot force third-party providers to put it everywhere. And yes, it has a cost, but even beside the cost, you cannot expect, you cannot rely, I mean a production DBA or me as a support engineer, on always using the top-notch, the latest development and forcing developers to put instrumentation in place for you. That would be great, probably, but it doesn't happen. One of the reasons as well is that it's a historical thing. So ask Monty, does he consider performance schema useful? I asked several other developers. They want to see raw stack traces, they want repeatable test cases, but they never want a performance schema.
I just say that I don't regard it as useful for my work, but I know customers have. The reason I was suggested off by default was that we had some users who got the 25% impact on it.
Yes, yes. Facebook was one of the first adopters who tried to use it at the early stages, and they found out that for production load it's too much a cost for the value they may get. So this same value they may get elsewhere, and right now Facebook uses a kind of profiling I will be speaking about at all their servers, covering everything from the kernel to all the applications. So what things I will speak about, they are more lightweight than performance schema, and they are uniform. They equally apply the same tool, the same approach, from the device drivers to hardware monitoring to Linux kernel to TCP stack to memory allocation, all the way up to the latest and greatest application of all times they are running on that stack. So it's all uniform.
But we do have plans to at some time allow people to enable it after the start.
Yeah, that would be great if it's dynamic. There is again some cost, some work to do. My personal item, the last item that what I care about, you know, a typical profiling query that checks the slowest running query in stages they spend time on and waits on each stages would take an entire page, an entire slide. So there is a kind of solution offered by MySQL to that in the form of C schema, and we have Oli from Dual who is sometimes spending some efforts on porting C schema to MariaDB that is not yet there. But personally, I would not be able to type this query easily. I need to copy-paste it from somewhere. And to run anything with performance schema, you need two things. You need to be able to connect to begin with. And this is a query that, well, it's not that complex, but it would take some time and resources to run. This is a point of performance schema. They try to not spend resources on data collection, but when you query the data, you need to spend resources. You need to aggregate. And if you have huge counters, gigabytes or hundreds of gigabytes of memory of performance counters, running this kind of query will take you time. And it may be already at the stage when the performance is key. So, what do I suggest instead? Instead, I suggest to use tools that are presented like to the left and covers full application stack. This slide is borrowed from, well, you guess, Brandon Gregg. Nothing special here. Of these tools, some are used already. One of the talks I've suggested for this them was specifically about perf profile. But there are a number of tools. They are kind of evolving with each Linux version. And why there are different tools, what they provide, what they have in common, and what the point of inventing new tools. This is what I would like to speak about. So of all that tools covering full stack, today I will mention specifically in more or less details that matters. The initial ftrace implementation, that's the basic, that appeared in Linux 2.6, 2.27, so it's in CentOS 6 and in Red Hat 6. Perf is a bit out of topic, but it's used as an example of the tool from the same age. Then at Linux kernels late 3.19 or whatever, and early 4-point-something version, so-called extended BPF tools appeared. And starting from 4.9, as far as I remember, we also have a convenient, useful interface to all that stuff called bpftrace. So that's specifically what I suggest to use, or try to use. It's not so uncommon to use operating system level tracing and profiling tools for MySQL DBAs. Probably every one of you tried to use strace at some stage, even though it's not a lightweight monitoring. It's a hard stuff. But even recently, we have a Japanese customer explaining to us why our thread pool is not working properly for their use case, and they did it by running strace and understanding what system calls happen in production under high load, because in artificial, simple testing environment it had not happened. So the entire idea of using operating system tools, even hard impact one, is not new. People attack GDB. There is pt-pmp that is even more hard. So the idea is not new, but what we should care about, we still should care about the impact. So if there are new tools which are more lightweight, we should not ignore them. Historically, the first implementation of tracing I'm interested in, fully dynamic, covering everything, all the application stack, it appeared in Solaris, and it was called dtrace. It was quickly ported to macOS. Like 10 years ago, it was already a big deal. It was used in FreeBSD and everything. After Oracle acquired all that stuff, there was a period when it was taboo, no way for Linux because of the license. It's not yet the case. So dtrace is like a father of all the tracing utilities. It introduced the approach, some kind of event sources that we may trace and everything. Good news to those who use Oracle Linux. Do you use Oracle Linux kernel? Is that dtrace is already there. They are like merged with Red Hat and put dtrace all over the kernel. Bad news for everybody else is while the software itself is already GPL and it can be merged, you can do that. I tried to merge this recent dtrace probes all over the full stack from the kernel to recent Fedora. It took half a day, failed, and it was then I realized that whenever Fedora updates, whenever I get new kernel, I have to start anew. So my message about dtrace is simple. While there are a lot of dtrace programs, while the approaches are great and should be studied, in production, in real life case on Linux, we should not and may not rely on dtrace unless you are an Oracle customer who runs Oracle Linux. So forget it. Another thing, yep.
I don't know, in CentOS 7.3, I'm doing a build bot now. It builds btrace probes in, well, it belongs to system tab, but it provides client btrace like interface.
Yes, that's the next step. So the ideas of dtrace, while we were not able to use dtrace in Linux.
I mean dtrace probes inside the source.
Yes, they exist. So the language, the same macros were re-implemented in frames of system tab, and they exist. What I probably missed on that slide, that in case of MariaDB, at least default builds, how I do them, they do not enable dtrace. Fedora, for example, does enable dtrace. So we have that static probes in, for example, 10.3.18 binaries provided by Fedora. In my case, we do not have that on MariaDB options. What's worse for you long term is that if you are also caring not only about MariaDB but Oracle do not provide probes in 8.0. So they already choose their way, and it's far from dtrace, even though they provide dtrace in their Linux. So what about system tab? System tab, you need to know about it. Check the last slide. It's also a full power tracer at the level that I'm interested in, and it was useful. It was useful for one well-known use case in MySQL land. Specifically, at some stage, MySQLD processes was killed in too many occasions, and there was no record of anything. Who killed that? Was it a manual shutdown? Was it a kill signal? If it's a kill signal, where it was coming from? Recently, there are at least error log entries explaining that if it was normal shutdown, then it was from a specific user, it's written down. Several years ago, it was not the case. So people successfully, including myself, used system tab on Ubuntu to trace specifically which process sends us a signal. So system tab was useful. It was a great profiler, but it crashes. Not only because it was badly implemented, there is one problem with the way it was implemented. So your system tab programs that looked like dtrace programs were converted, compiled into a kernel module. So that kernel module was loaded into the kernel. And with minor checks, how safe is it? So as you have a full-featured programming language at your fingertips, you could write all kinds of wrong stuff, and it could crash a kernel. That's the last thing you want in production. So that your instrumentation crashes the entire set. Just kill MySQLD, just attach DDB, generate core. It's much lightweight and reasonable. So again, my message is simple. Forget at the moment about system tab. These two tools at the same time had provided a useful framework for collecting stuff. So by profiling and collecting stuff, I mean executing something or doing something when some event happens. All the events we may care about in Linux system may be split into four categories: kernel events, so system calls, or application system user space events. That's one direction. Another direction, if they are already in the code, are they hard-coded? Well, had they required manual work of developers of kernel or application system? Adding dtrace code requires changing of the code. So if it was not there, then it's not for you. It's not present. Or it's fully dynamic. So are you able to change the code on the fly? So from this point of view, there are four kinds of event sources. Kernel probe, it's dynamic, changing of the code in the kernel. Kernel trace point, it's dtrace kind of trace point already present in the code when it was compiled. User probes, that's what specifically I care about, something that you can add to your application code on the fly when you need it, independently of whether developers even had in mind any possible usage of this kind. So you do not care. They write their stuff, you write your stuff, and you can merge it into a running binary on the fly. And user-led statically defined trace points, it's what dtrace introduced. So one way is to have event sources. Okay, you can add something to generate the events. Another way is to how to work with them. Basic foundation was put in kernel 2.6 with ftrace framework. That was created initially for the kernel itself. So it was, at some stage, kernel developers understood that they cannot rely on, building debug kernels, trying to reproduce test case, and then getting all the profiling information they needed something else. They needed to be implemented in such a way that it doesn't affect performance when it wasn't used. So you can find in the internet how it was implemented, but basically the idea was like that. In the beginning of every function, there was inserted an instruction that by default is no op. Instead of that no op, you could dynamically, via the linker, introduce another instruction that eventually was calling your probe code, some code that is introduced there. And at the same time, you could replace it. So there were different approaches. One simple is to call a function that can do nothing, or do something. It was found out that it's too complex, it adds too much overhead. So they invented a bit smarter thing that was then tested and made up to work on multiple CPU environments. You need your CPUs understanding your code in the same way. So it ended up with interrupt 3 introduced there a breakpoint. So instead of no op, you introduce a breakpoint, and on breakpoint the CPUs have to sync. And then after that breakpoint, you either call your probe code or something else. So, and the probes were added with ftrace that were working in a really simple way. We have a file system. What can be easier than working with text files in a Linux system? So that was the very first interface. You were mounting initially debug.fs or later trace.fs somewhere under sys kernel debug or sys kernel debug trace, depending on the version. And when you mount it, you have a set of files, text files. You can read from these files to get your tracing results or available traces, or you can write to these files. Similar as you work with prods, for example, file system. So you can write to the files to enable specific trace point, tracing in general, and whatever. So it's a really simple interface. Based on this interface, different frontends were added with time. In kernel 2.6, perf profiler with perf events was introduced as actually a frontend to this basic tracing mechanism. Later frontends include, but are not limited to, so-called BCC tools and bpftrace that are specifically a point in my talk. So still right now, even in CentOS 6, that's what I tried myself, in all reasonably old kernels that you may find in production, you need nothing else but ftrace itself to actually add the dynamic user probes to any, not every other line of the code. With perf you can see to which lines of the code you can add it, but to any instruction. So you can squeeze your breakpoint in between instructions. You cannot squeeze it in the middle of assembler instruction. If you try to do that, everything will break on execution because you will get a wrong command. But in between instructions, you can do that. So it's done as simple as follows. The example is in this case from Fedora core, but it works equally well on Ubuntu. And with minor changes to the names, debug.fs versus mount, for the mount command, it works on CentOS 6 as well. So you have a number of files in the tracing directory, and you can create a probe. Here the probe was created with perf, honestly, and you can see it. So the probe says that you have to attach to the MySQL binary coming from this specific file. It was a binary built by myself. And the probe is for instruction with that address from the beginning of the address space of this binary. And this instruction, this probe got a name. It's a user probe, hence P. Probe MySQL, it's like a class. If you would not put that part of the name, it would be probe dash and your binary base name. DC is the name of the probe, and that's it. There is some other probe as well, called DC1. Okay, I have two probes at the same, at different addresses, whatever. So this is how it looks like. This line was added by perf, but you can add it manually as well. So, is it easy to work with these two manually? Yes, it is, and the next slide shows it. So, how it was done actually? It was actually a writing the text of the probe. In this case, the probe was for the same address. The address is the beginning of dispatch command function. How I got it? I got it easily by obj.dump. So, I found function that mangled name looks like dispatch command. It does not understand, the interface does not understand C++ directly. It needs what is written in the object file. Then I found this address, and at this address it's an entry into a function. You have some syntax, it's quite simple and explained in the kernel sources itself, that allows you not only to just trace, to register the fact that you were there at a specific time, but you can parse the arguments. So in my case, in my probe, what I did, I found out how the arguments are passed to the function. They are passed via registers. First 6 arguments are passed via registers. You should know which register they are. Even though it was a 64-bit, it's just a third argument. Yep.
If you're talking about production or debug builds, then
it's not about debug builds. It's
so load addresses are pretty much always randomized and part of it.
There is one step that I skipped here. You can, in general, you can even attach to a prod file system to the memory image of the running process.
So you will be done on the memory image?
Yep. But here, that was done on a live system with Fedora 10.3.18. So all I needed is, well, in some cases, if it was a trace point in the library, you need to know base address. But that's just the address I got. I tried, and it worked.
So it automatically deducts like base address?
Yeah, so I got it from, in this case, I got it from objdump for this specific process. And no matter how times you try, you get the same address. Yeah, even before that, I got it from the perf probe added via a bit safer mechanism. There are cases when you have to guess about that address. If you want to trace not the entry to the function, then you have to add more and more things, but you actually can put the probe on multiple lines probed inside the function. So every other line of the code can become a probe this way, this simple way. So what I'm doing there, I'm printing as a string the content of the register with shift 0 from the beginning of that memory address. So it's a third parameter. Third parameter is a query text, so this, the example that goes through all this presentation is related to capturing the queries. It's not a big deal, but you can really get the text of the query. It gets more complicated if your parameter is not a simple strings but structures. You would have to compute somehow for ftrace, you will have to do it manually, the offset, the shift from the beginning. It's, I am not saying it's easy, I picked up an easy example. But it already, it's more complicated for MySQL, for example, because they use structures at that stage.
Just a question on this example here. So here you add a row to this command.
Yep.
Yeah.
Then I enable tracing of specific probe and enable tracing in general.
So when you put that probe, like there's no reference on any PID in there. So can you...
there is a reference to PID. So what you have in square brackets is a reference to a CPU number, and what you have after MySQL d dash is actually a part, unfortunately not a full PID. For short PID, it will be literally PID.
So basically my question is, when you add those probe,
it applies to all binaries starting from these files.
So you can put the probe even before MySQL d is running?
Oh, yes.
And you can also put the probe even if MySQL d is already running?
Yes, it was always running in this case.
So like it looks about like the linker, like the random, I don't remember exactly the randomized address space, that this is completely independent and that happens even before.
So it has to be deducted in the base, base and
because if you can do that before, even if it's randomized after, the magic will happen.
I actually, what I figured out from objdump is like a offset from the beginning of what was dynamically allocated. So this offset matters. It's more complicated in case of S or dynamically awarded libraries, because it's like yet another case. So as with usual with my FOSDEM and all other presentations, a lot more details of how I did it, they are presented in the blog post. Interesting part here is time. So for each probe added via ftrace, you have a timestamp, and it's quite detailed. So you have a timed events, automatic, things that you have to enable separately, for example, with performance schema, if you want just counters, or if you want to know the time of each and every occasion. So it works, but it's a bit complicated. So you have to find out where to attach the probe. What's worse? In case of probe, you have a static printout of what you put. What if it's good for getting raw data? It's good for getting. You can, with different traces, you can get stack trace at the moment when the probe executed and many other things. So it's low level and it's a bit complicated to work with, but the worst part is this. What if you do not need this raw data, but you need aggregation? What if you want to have smart probes, some code that checks this raw data, summarize something, like collapses stacks, for example, as pt-pmp does. So for this you need something else. And here, when so-called eBPF framework was added to the later kernels for this specific reason. Initially, the name comes from E, extended B, Berkeley Packet Filter. It's FreeBSD's firewall. So for that, for process complex firewall stateful rules, they invented a way, implemented, and it was then borrowed from by Linux actually, so that you have to write a code, some program, but it should be safe because it runs in kernel's context. So it should be a virtual machine. So they added an LLVM virtual machine, added a way API that would generate the code for this machine. You write your probe code using this API. It's translated into a bytecode. Some checks may apply for safety that you do not have a did loop, for example. But even if checks fail, in worst case, what you will have your virtual machine fail, but not the kernel that runs it. That's the point. So for smarter, more complicated probe codes, this was later invented. In practice, you have used the full power of this stuff starting from kernel 4.9. There is some history behind that, so in which kernel version what was added. 4.9 added a way to use eBPF tools as a real profiler as well. So the last thing that was added is a probe that runs every time you want, so with whatever frequency per second, like a real profile. So now you have everything, you have in perf, now you have everything that you have in ftrace directly, but with the ability to define a program. And for the API that was initially in C, there were later bindings added for Python for simplicity, in C++ and whatever. And after that, so-called BCC tools appeared. So these are already Python implementations that you can get for typical stuff. So do not bother much about specific tools that I reviewed. TP-list just lists dtrace probes if there are any. This is how one of the ways to find out if dtrace is compiled in or not. Another interesting tool that was created by Brandon Gregg specifically for MySQL, QSlower. It does what my previous probe do, but relies on a dtrace probe at the beginning of the query and at the end, so it logs the queries and measures execution time for them. It's like a slow query log on the fly that can be enabled, and unlike the real slow query log, there are no writes to disk until you need them. So you control how much information you need, or you can actually try to go much farther. But still, it's getting curious is at your fingertips. So it's not so much to type, you just run the tool that you can build. There are some build problems, but it works. So the last line, the last item is for myself, and I did it. So the entire point of using these tools versus perf or ftrace directly versus attaching GDB at some intervals is to measure the impact. How much you slow down your execution. So and that's what I tried to show, at least for a simple example. Another useful tool that actually does again what my manual attempts to work for bpftrace did is called trace. It allows you to attach user probe to the beginning or to the return of any function using the same syntax more or less for the probe, and a bit different syntax for printing the arguments. You do not rely on the way how arguments are passed. You do not need to know which registers are used for which parameter. You can refer to them by name. Or in simple cases, when you do not even have a symbolic information, you refer to them as argument 1, 2, 3, starting from 1. So I'm printing argument number 3 as string, and it's actually a query that was executed. Okay, the format is a bit different. Again, you have a non-mangled correct process ID. That's what you cared about. Unlike ftrace, it accepts arbitrary lengths. It does not print just four last digits. You have thread ID, so you can distinguish queries coming from different threads. You have the binary and whatever. So the format is quite tunable. Again, I have a blog post explaining how this can be used and given even more. So on top of that, what we have recently, specifically in my Fedora 29 and everywhere starting from kernel 4.9, people decided that while for programmers, for serious teams like Facebook has, writing Python or C code of BCC tools using a raw API gives the most flexibility. For quick usage of people like me, Brandon Gregg himself, who need to get a quick pick on what happens. out of nothing, without any previous idea of what we are looking for. Just try this or that. We need something better than writing a Python code. That can be a bit complicated, but still more flexible than just attaching the probe and getting simple printouts. So they invented another tool called bpftrace. The code for bpftrace look like the AWK code. So you have a probe, you have a template that the probe that actually was captured should match, and then you have a simple program without loops. So it's condition, action, probe, condition, action, done. And this program is read once. Each template is matched, each condition, if it's satisfied, leads to execution of the probe text. And when we ended up with this program, we are done. So that it's safe in the sense that it doesn't have loops.
So, I don't know if you remember, Valerie, when we were hunting this bug in MariaDB where like there was a full table scan instead of an index. So Monty provided me with a debug build to like see what was going on. Basically, with all this, like
you would not need a debug build.
We could have done this without the debug build by putting the right trace and basically running on something without stopping production, like just connecting on this.
Without need to wait and without need for Monty to bother to add printouts
and to compile and so.
The thing is that with the debug build, I also get the optimizer choices and why
theoretically, you can get this as well. It depends on you. It would be a simple single probe. You may need more.
But also, like for me, when we were hunting that in production, that also means that I don't have to restart MariaDB.
So you can do much.
Instead of a debug build, you could provide a team that says right probes and pretty fair ways.
Yes. So that's what I'm defending. And unlike with ftrace, that's really complicated for a normal human being for trying more than once. With this stuff, it gets easier. Moreover, I put a comment to my blog from Fedora maintainer of bpftrace, who told, for example, bpftrace does not understand C++ names, so you need to use manual names. In Fedora 32, that's already fixed, so people are working on that. This is a live stuff that everybody cares about. And as it's used, for example, in companies like Netflix, where Brandon Gregg is from, or a company like Facebook, it's already tested at scale that all of us might just dream about. It's far beyond what we will see in practice in the majority of cases. And it's also already applied from day one. It was applied to databases. So Brandon Gregg, in every second example, uses either PostgreSQL or MySQL because that's what people use in real life. And it's also applicable to running in containers. It's about beyond my knowledge and my experience because I don't do containers so far like very much. But it works. So
basically what you're telling is, as a support person, when like now instead of like telling me, hey, attach GDB at a breakpoint to this, run this BPF trace.
There is some common problem for both approaches, but it's way easier. Just run a tool that you can, in Fedora, for example, you can get it from repository, but it does not look like a hack. It looks like a normal use tool to work in the system. So there is a bit different syntax for the probes. A trace point is a static probe, uprobe is the beginning of the function.
Can you get the return value of the function?
Yes, uret probe. That would be.
For example, here we get the file that's open. I would also like to have a file number.
Yes, you need just another syntax for a probe. There is a separate name for a probe, uret probe in case of, and that would be, I don't remember, maybe trace point or trace pointer in case of static probe. So yes, by default, it's a probe that you put probe at the beginning of the function and at the end, and you can get the exit status. So you may find out if it fails or not. So I have, well, I just highlight the fact that for me it looks like AWK. So what you have here, there is a probe. Let me give you a better example of what I did. That's a thing that worked only on Fedora, cannot work on Ubuntu because it's a recent edition. So I've created a simple replacement for pt-pmp with bpftrace, lightweight one. So what I need to do, I have a profile probe that probes at the given frequency. It can be not just 99 Hertz, it can be 99,000. and still reasonable. So I will not miss any stack trace, unlike with GDB. So for that, I have a template. If common is MySQL I can get execution of every process in the system, but it will be a bit more overhead. If I'm interested only in MySQL I say, please print me, that's my stuff for my whatever reason. I would like to split stack traces one from the other, so I put a comment of a kind. Print me a user stack in perf format. By default, format is doesn't include address and it's presented below. bpftrace own format. So print me user stack. At that same moment, I can ask print me kernel stack. Where in the kernel line at the moment, I can split them. And that's what Brandon works to do. So that's what I get. And put it aggregated. In this case, it's just user stack. They are not aggregated, but in reality, you can have an associative array with a stack trace as an index, and number of times this specific stack trace was noticed as a value. And that's pt-pmp already implemented in one command line.
Yeah, without the 5 seconds.
Without the 5 seconds or whatever. So now the final test that I did for this presentation specifically and never before, I tried 3 things. First, apply pt-pmp. While the sysbench test was running, I picked up a simple one, OTP point select, so that I get on my outdated hardware and get some numbers that I'm not sharing to see. It was pretty much default. MariaDB. So perf, record, and bpftrace profiling with associative arrays that I used. So I've counted how many times already inside the probe. I have not written each and every step, but I aggregated them inside the probe. So what I got as a result, pt-pmp I just got the output on screen already aggregated, that was cool. But slow. In perf I got 5.4 something megabytes written of the file that then I had to process. And in case of aggregated bpftrace probe, I've got 2 times, not 2 times, more or less 2 times smaller file of already aggregated stacks. Performance drop, that was I care about. So first number is what I got without any profile. With pt-pmp attached for 60 seconds. The test was running for 60 seconds. I got 56%, so notable like 40% performance drop while pt-pmp is running because it's attaching GDB and detaching everything. And it could just hang, it happened sometime with GDB. Then with perf, I've got 98%. That's what you can get in CentOS 6 2.6 kernel anytime. So the same tracing capabilities with only a fraction of performance. And finally with bpftrace, because you already aggregated that during you process the probe, I've ended up with like 99, almost 100% of performance with 12 threads, so I had more threads than CPUs. It's non-scientific experience, non-scientific experiment. It's one time, like one test, but well, you can repeat it multiple times. The trend is clear. So it's a lightweight replacement for pt-pmp, and actually there is an interesting branch created by Ranger, by Alexei Stroganov from Percona, pt-pmp, where you can put any tool. He put QuickStack and some other tools to get stacks faster to get with GDB. So I expect that next step for me would be to put bpftrace there, because to do real aggregation, and you will see it in blog post, I have to get that aggregation AWK program for pt-pmp to collapse the stacks, for example, for perf. Here I would like to see the same advances, same options to process stack traces as pt-pmp. So the last but not the least, if I have time, that stuff was already presented at FOSDEM yesterday, flame graphs. So there is nothing unique in flame graphs. They were used for quite a long time. What they are good for? From perf, for example, you collected the data. You can get, if you collected with -G option, you can get whole stacks. You can present that as a huge tree of where the time was spent. For any complex process, you will get the output many pages long that is hard to interpret. So your idea in general is to find the problematic point. So what flame graphs brought to us is a way for any tool, it does not matter which tool is used to collect stack traces. So they can be aggregated and presented in a way that you may find interesting or useful. So you will not find it useful in this slide. Let me try to do it alive. So these files should be viewed in the browser, SVG files. Yeah, it's really more interesting. So what you have here, I'm not sure how is it visible. The principles were explained at Fosden. In any case, you have boxes. So the wider the box is, the more samples with this frame were noticed during your profiling. At the top there, you can find current frames, so what was executed at the moment when we took the profile. And you can actually click on this stuff. Okay, let me click here. Can find out all the underlying stack trace and see how much time was spent on this specific stuff. So it's a quick way to view, not always quick, okay. Search and everything. It's a quick way to understand what are the most popular stack traces and how we ended up. Yep.
What is the gray line and data name? Something you could resolve?
Yes. When we have just numbers, it was done for Fedora coming, for MySQL coming from Fedora. Some symbolic information was missing, some symbolic information for libraries were missing, some kernel symbolic information were missing. So yes, one of the problems with this stuff, that for it to be really useful, you need to have symbolic information for everything. If it's missing, you will get just numbers that you can figure out what they're about, but it's not that fun. So I would just suggest you to check sometime these links from this slide to find out different types of flame graph exist. For example, you can trace the memory allocation, trace mallocs, who allocated memory, how often and stuff, who did disk I/O, why you were stopped executing on CPU, so that's off CPU flame graphs, what you were waiting for, and all that. So it can be applied to any profiler tools. There are special scripts, different kind of applications because different format of stacks for perf, for bpftrace, for BCC tools, for dtrace, for whatever. So it's a bigger thing flame graphs than just covering Linux. And you can get it using these tools. So I'm going to the end of this presentation. What are the problems with this approach? So why it's not widely used yet? First of all, for a typical DBA, you need sudo and even root access. If you don't have it, neither ftrace, no perf, no GDB helps you. So that's why in some cases all you have is performance schema or other show commands. So you need them. The program that is traced, the code is changed on the fly. So if you at the same time will attach GDB, you will get interrupt 3 breakpoint, and then the code does not match the image, so you cannot debug the program why it's traced in a reasonable way. How to make probes less intrusive? Okay, use bpftrace. It's already trying to do the best to not allow you to do bad things.
What about the supply? Do you actually need root access or do you need access through MySQL? For GDB, you don't need.
It depends on operating system. For example, on Ubuntu, even for MySQL that I built myself, for perf to attach, I need sudo access. So there is a file to tweak for that, but it really depends on distribution. In some distribution, to get access to ftrace, to ftrace events, you still need root or sudo access. It does not matter that you own the process that you are tracing.
I can tell for kernel stuff, you probably might need to watch it for GDB that you don't need to.
So I have not studied it really carefully. What I noted that in some cases for ftrace, I even have to do sudo su to get real root because probably of up armor. So even go as far as that. So simple sudo was not enough without coming to more details. So there are problems like everything should be ideally built with frame pointers, you need debugging for and everything. The most important problems are at the end, I think. So surely you have to install more tools. In case of MariaDB, for many customers, tools like GDB and perf is a part of a tool chain that we demand them to install eventually. These are new tools. Nobody has this installed. My experience with Fedora 29, quite new at the moment when I started. Now it's already out of support. Was that you have to recompile BCC tools and bpftrace from current source code for it to work, because the package was outdated. Kernel changed, API for these probes changed, and every attempt to use bpftrace just crashed, even though it worked in October, for example. So all happened in the meantime with some updates, but no update for bpftrace RPM. So you may not be able even to rely on normal package for this stuff. That's a problem.
So maybe compile and figure out the kernel that you're using.
Yes, when I provided all the details for current kernel headers and everything, it compiled, it worked perfectly after all, and it allowed me to complete this talk in general, because I was stuck, I don't know how it comes. It worked in October and now it doesn't work, it crashed. That's a bad thing. That's it. Is it a crazy idea in general to ask DBAs to use yet another set of tools? Maybe, but I think it is not. There are way more crazy people who does this with Oracle RDBMS. So they do not have access to source code and still find some value in creating dynamic props out of experimenting and still finding good stuff, because they can trace everything in the kernel and then come up with some addresses that every time are there, and then make some conclusions, maybe go to the binary, find out what happens in Oracle RDBMS inside. We have full access to the source code. There is no excuse not to do this stuff when it allows to get a low impact profile. The last but not the least, I would like to thank MariaDB Foundation and Anna Videnius personally for making a table for me to go here, because it's a developer conference for corporation. I'm not a developer, it would not happen otherwise. If you have questions, I'm here for you. If you have nothing better to do in all problems with MariaDB, please report the bug. It's my usual message for the presentation. Peter Zaitsev reported the bug. It was already found that for select from information schema in a DB mutex, we do not have a name. We do not have a name, not only in 10.4, but in 10.3.7, there will be a bug. So when you're at the conference, you might be speaking about good and great stuff, you can still find and report a bug. Somehow it wasn't reported. It shows that even basic SQL level tools, access to profiling information, are not widely used, so nobody cared to see them until recently. I hope that would not be the case for bpftrace and other things. Thank you. If you have more questions.
Unfortunately, you are still on RDOS 7. Is there anything of this I can still use? Or is
You can use ftrace and perf, starting from.
Yeah, but I think also perf.
Yeah, it would be perf. It would be perf with bigger impact than this recent tools.
Yeah.
But still you can add dynamic probes. The main idea that you can add any probe you need. You can pick up any variable at any specific step in any function, in an extreme case.
But then you have to use this ftrace way of
yes, you have to calculate the address. Or with the help of perf, there are perf commands. Unfortunately, that talk was not accepted anywhere, but it's in my blog post. I had, in case of Oracle, I had to pick up the query from some line in the middle of the function, where it was already copied properly to a local variable. So that works. But basically, it ends up calculating proper offset from the beginning of the function, or from the beginning of the actually executable image. In worst case, your probe will crash. It happens often, but nothing else would suffer. So if you did something wrong, you will see it immediately.